Okay, in this video, we're going to focus on the exterior angle theorem. Okay, so the exterior angle theorem is really a little bit like an extension of the triangle sum theorem. And remember, in the triangle sum theorem, we said that the measures of the three interior angles would always sum to be 180 degrees in any triangle. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles of the triangle. Heck, what does that mean? Okay, well, I guess if we define what an exterior angle is and remote interior angles, it'll make a little more sense. All right, so an exterior angle is the angle adjacent to a triangle that's formed when you extend one of the sides of the triangle. Okay, so if I'm looking at this diagram down here, I've extended one of the sides. I'm looking for an angle adjacent to the triangle. Okay, so this is the angle that we're talking about. This is the exterior angle right there. All right, now you can form 6 different exterior angles in a triangle depending on how you extend sides of the triangle. So you're always looking at which one am I interested in. Okay, so that's what an exterior angle is. Now, the remote interior angles, well, they're going to be the interior angles of the triangle that are not right next to the exterior angle I was talking about. So this is how we say it. A remote interior angle is one of the two interior angles in a triangle that is not adjacent to the designated exterior angle. Angle O and angle D are going to be the remote interior angles. Okay, so like we did before, let's take a second and prove this to be true and then look at a couple of examples. Okay, are you ready? We're given triangle DOG. All right, and we want to prove from that triangle that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3. So let's take a look at the diagram that comes with this proof. We have triangle DOG, okay, and we are trying to prove that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3. Okay, do you see how that's the exterior angle and these are the two remote interior angles, or the two inside that are not right next to that one? Okay, so we're going to start with what we're given. And in this case, we're not given a whole lot, just that we have a triangle. Okay, so we're going to start with triangle DOG because it's given. Okay, now we can use what we just proved. What did we prove in the last video? Okay, hopefully you can say which angles sum to 180 degrees. Got that? Okay, so hopefully you were able to identify the interior angles. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 all sum to 180 degrees. We know that because of the triangle sum theorem. Okay, so that's one piece of the puzzle. Second piece of the puzzle, we need to concentrate up here. Okay, what do we know about that angle relationship? What do we call that kind of angle relationship? Hopefully you are able to say that's a linear pair. And what do you know about that? The measures of the two angles must sum to be 180 degrees, and that's called the linear pair postulate. Okay, so the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees, and that's the linear pair postulate. All right, now what do you notice about those two lines? You see they're equal to the same thing? Anytime you've got two things that are equal to something else, we can set them equal to each other. Okay, you can either call that transitivity or you can call that just substitution. If we're just substituting this in right here, either one of those is fine. Let's use transitivity because it's kind of a fun word to use in our proof. Okay, so what that looks like then is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 4 is equal to the measure of angle 3 plus the measure of angle 4. And that's because of the transitive property of equality. Okay, really all this means is if you know this to be true, if A is equal to B and B is equal to C, then you can say A is equal to C. Okay, take out the middleman and you're good to go. So that's what the transitive property of equality is. So a little sidebar there. Right, so what do you notice coming back to this statement? What do you notice on both sides of the equal sign? Hopefully you see it. Do you see the measure of angle 4 is on both sides? So I can subtract it away from both sides and that equation still is equal. Oh my gosh. So what does that look like? The measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3. Voila, we have proven the exterior angle theorem. Why can we say that though? What do we do there? From this line to this line? We just subtracted, so we can just call that by subtraction. Okay, so now let's look at just a couple of examples of problems that apply the exterior angle theorem. All right, let's give this a shot, shall we? Let's look at this first example. Do you notice anything in this example? What are we looking for and what are we given? Okay, what are we looking for? We're looking for this angle over here. What is that kind of angle called? That's an exterior angle, right? And we know that the measure of any exterior angle is equal to the sum of the two remote interior angles, which we're given. So to find the measure of this angle here, all I need to do is add these two angles up. And so 28 degrees plus 58 degrees, that's going to give us, I think, 86 degrees. Okay, how about this one over here? I'm looking for x in this case. And what am I given? I'm given the measure of angle C is 46 degrees. The measure of angle D is negative 1 plus 8x degrees. And the measure of this angle on the outside of the triangle is 18x minus 5 degrees. Again, I see the relationship that I need. The sum of these two angles will equal this angle. Okay, no. The sum of the measures of these two angles will equal the measure of this angle. So I can just set up an equation and solve. So what are we looking for? We're looking for x. Okay, here's our equation. 46 degrees plus negative 1 plus 8x degrees equals 18x plus 5 degrees. Let's use our mad algebra skills and solve for x. Okay, so if I simplify the left-hand side and take everything out of the degrees because they're all degrees, right? I've got 8x plus 45 is equal to 18x plus 5. Let's subtract 8x here. Let's subtract 5 here. And I think we're going to end up with 40 is equal to 10x. And that gives us x is equal to 4. Now, if I really wanted to be confident in my answer, I would go ahead and sub that in because I should be able to then verify that those two angles will actually sum to this angle. All right, well, let's head over here to this one. Okay, in this last example, we are given the measures of two remote interior angles. We're also given the measure of one exterior angle. And since we know that relationship now, I can equate those and use the equation to solve for x. So if I equate the two interior angles to the exterior angle, I'm left with this equation. 89 degrees plus 5x minus 7 degrees is equal to 14x plus 1 degree. Right, so now if I clean up the left-hand side, I've got 5x plus 82 is equal to 14x plus 1. Let's subtract the 1 on both sides and subtract the 5x on both sides. And we should end up with 81 is equal to 9x. So x would equal 9. Now that is not the angle measure. I need to go ahead and sub that in to find the angle measure. Okay, so now when I sub in that 9 to that expression, I get 5 times 9 minus 7. 45 minus 7 gives us an angle measure of 38 degrees. And aren't we proud of ourselves? Next time we're going to hit up another triangle theorem.